Hey everyone, this is Mr. Thompson, and today we're gonna talk about a topic that can be difficult in chemistry. So it's really important that you pay attention. Rewind through this video if you got to. Go over this material and be sure and ask questions about it in class because it's real easy to get confused on this. All right, so I'm gonna jump in. I'm gonna kind of take us forward from where we've already been. I mean, we'll take a look. With a chemical reaction, a lot of times elements, atoms are being rearranged. So for instance, right here we can see this is a double replacement reaction with the silver nitrate, the sodium bromide. They're going to replace each other. We get silver bromide and sodium nitrate. Nothing too special about this, okay? I can show you another reaction, such as this right here. Sodium and chlorine gas make sodium chloride. That's table salt. And I know you're sitting there thinking, well, there's not anything special. We've seen this before. But let's take a little bit closer look with this, okay? So here's my reaction. Sodium is a neutral atom. It doesn't have a charge or anything. You can see that. This chlorine, it's diatomic. It means there's a pair. There's two of them. But it's also neutral. We look at sodium chloride. It's also neutral. I know you're thinking, well, what the heck is the point? Well, if you look, even though this sodium and this chlorine were both neutral, and this compound is neutral, if we look at them individually, sodium and chlorine right here, they are not neutral, okay? These are ions. This is an ionic compound. And so in order to form it, sodium chloride, the sodium gained a +1 charge. The chlorine gained a -1 charge, okay? So we had elements that were not charged, but in the process of reacting, not only did they combine to form a compound, but they also changed a little bit. The atoms, the molecules changed a little bit to form these ions. So let's take a look at it individually. I'm going to cut this reaction in half. Let's talk about what happens to the sodium. You start out with sodium, and in the beginning it was neutral sodium. But then at the end of the reaction, we had sodium that was positive ion, Na+. And so what happened was these two sodiums, each one of those sodiums lost an electron to become positive, and so what we have here, as you can see, is we have the positive sodium plus the electron. Okay, of course it's 2, 2, 2 because that's what it said in the equation. But so each sodium had to lose an electron. If I take a look at the chlorine in the beginning was positive, but in order to become the chlorine we needed at the end, the negative, it had to gain 2 electrons. So this chlorine, which was neutral, gained 2 electrons so that each one of these chlorines, because the subscript does matter, each one of the chlorines now has a negative charge. And if we put that all together into one equation, including the electrons, we see I had neutral sodium, I had neutral chlorine, I took 2 electrons and I added them to the chlorine to make it negative. And so what happens is when these combine, the sodium becomes positive, so it loses 2 electrons. So you can see they're kind of on both sides, so they're not really that big of a deal, but this is what's happening during this reaction in order to make sodium chloride. The sodium had to lose 2 electrons, the chlorine gained those electrons, and then it combined together to make that ionic compound, sodium chloride. Okay. Now, don't worry, because I'm not going to make you do that on any test or quiz. I just wanted to show you what was going on, what would happen. But what you do need to know, you do need to recognize that this happens, that the values change, and you are going to have to find some of these values. Of course, we've got some new vocabulary. These equations are known as oxidation-reduction equation. Oxidation is the process that increases the oxidation state of an atom. Reduction is the opposite. It decreases the oxidation state. So what does that all mean? When we've got oxidation, we've got reduction. Well, if an atom is oxidized, its oxidation state increases. If it's reduced, its oxidation state decreases. So take a look at this compound right here. Okay, if I break this apart, the sodium, it gave its electron to the chlorine. That was what its goal was. The sodium would be +1. The chlorine would be -1. Okay, this compound Sodium chloride is neutral. There are no charges on it. However, if they were broken apart, the sodium would be a +1, the chlorine would be a -1. So what we say is, even in this compound, the sodium has an oxidation number of +1, and the chlorine has an oxidation number of -1. So that's what oxidation numbers are. They don't have a real meaning in our world except as like a placeholder to think about it. It's like, well, what would happen if I broke this sodium chloride apart? Well, then the sodium would be +1 and the chlorine would be -1. Okay, then let's give them an oxidation number of that. I know that's a little confusing, but the more we practice with it, the better we'll get at it. And there are some rules that you will need to write down. Okay? First of all, if you see elements by themselves in an equation, such as sodium, okay, the oxidation number of any uncombined element is 0. So in our equation back there with the sodium, it had an oxidation number of 0. The only time it would have a different oxidation number is if it had a charge, such as the sulfur has an oxidation number of -2, because that's its charge, -2. Those are easy. If the element's by itself, it's a 0. If it's got a charge, then the oxidation number is that charge. It's when they get in compounds that it's a little bit trickier, okay? And you're going to have to remember some of these. You're not necessarily going to be given all of this on the test, so please make sure you got to study it, you got to practice with it. We've got a few rules that we got to know. First of all, fluorine, oxygen, and hydrogen always have the same thing. For our purposes, always have the same thing. Fluorine has a -1, oxygen has a -2, hydrogen has a +1. Okay? So that's, and it should make sense too. Based on their position on the periodic table, fluorine always got a -1 charge, oxygen always got a -2 charge, hydrogen always had a +1 charge. So that part's not difficult. That's stuff we already knew. I'm not really teaching you something new. I'm just giving it a new word. I'm calling it an oxidation number now. Okay? Group 1 and 2 elements, that's your alkali metals and your alkaline earth metals, and aluminum have charges of +1, +2, +3 respectively. So group 1 has +1, group 2 has +3. I'm sorry, let me say that again. Group 2 has +2, and aluminum has +3. Okay, so if you see those in there, for instance, calcium, oh, calcium's in group 2. It has an oxidation number of +2. No problem. The last one is a little bit more tricky. Well, what happens if I've got something like silicon and I've got something like chlorine? Okay, those are not group 1, group 2, group 3. They're not, we haven't mentioned those. This is the part that you have to remember. The most electronegative element will get an oxidation number equal to its charge. So for instance, chlorine always got a -1 charge. Chlorine is more electronegative than silicon, so chlorine will have a -1 oxidation number. Okay? Remember, for electronegativity, the closer an element is to fluorine, the more electronegative it is. Fluorine is the most electronegative element on the periodic table. So the closer it gets to fluorine, the more electronegative it is. So if you look on your periodic table, chlorine is really close to fluorine, especially compared to silicon. Okay? We're going to practice with that just a second. I got one more thing I want to show you. Okay? Here is the most important rule. In a reaction, the sum of the oxidation numbers in a compound, I'm sorry, not even necessarily in a reaction, but just always, the sum of the oxidation numbers is equal to 0, unless it has a charge, and then it's equal to the charge. Okay? Now, guys, get your vocabulary straight. This is where students will get confused. If oxidation occurs, it increases the oxidation number, which means it will lose electrons, which means the ion or the element or whatever it is becomes positive or more positive. If there is reduction, then it lowers the oxidation number. It gains electrons, which means it makes it more negative. Electrons are negative, makes it more negative. Okay? The oxidizing agent, this is a vocabulary term, the oxidizing agent is the compound that gained the electrons. Whoa, it's over here. Okay? The oxidizing agent, think of it, it's the one that causes oxidation. It causes oxidation. It causes something to lose electrons. Well, if it causes something to lose electrons, that's because it's the one that gained the electrons. So the oxidizing agent causes oxidation, causes you to lose electrons, which means the oxidation agent that caused it is the one that's going to gain the electrons from whatever it caused to oxidize. Okay? So, let's take a look at some examples. Make this real quick, okay? Write the oxidation numbers for each element in this. All right, so we got hydrogen, we got phosphorus, we got oxygen. Well, first and foremost, H is always +1. O, oxygen, is always -2. Those are always. All right? Now, this is important. The subscripts are a big deal. So the total plus right here is +3. Over here, oxygen is -2, but I got 4 of them, so the total is -8. Now, I told you, the compound is neutral, so that means everything has to add up to be 0. So we got to figure out what phosphorus is. We got to sit there and think, okay, the positive and negative side's got to be equal. Well, right now, the positive is losing, so we think, okay, well, what else does the positive side need to make 8, to make the -8? Oh, phosphorus must be +5. You will have to figure this out. So hydrogen is +1, oxygen is -2, phosphorus is +5. Okay? Let's try another one. I know that wasn't good enough. Write the oxidation number for each element in this compound. Well, this is ammonium. All right, this is actually an ion. It's got a +1 charge. We'll come back to that in just a moment. Remember, hydrogen is always +1. So that brings my total to +4, because I've got 4 of them. Well, what would the nitrogen have to be? You add the oxidation positive and the negatives, we're going to get +1, because that's the charge. So normally if we were balanced, we'd say, okay, the nitrogen is going to have a -4, so they balance out. But they didn't balance out. The positive wins. We have one more on the plus side. So instead of making nitrogen a -4, we're going to make nitrogen a -3. So that my -3 adds together with these 4 pluses and makes a +1 charge. Okay? Last one. Last example. I promise I'll go quick. Okay? Is this a redox or an oxidation reduction reaction? How can you tell? Okay. Well, some things we got to know. In this entire reaction, oxygen is always -2. In this entire reaction, okay, we've got to be balanced. So any uncombined elements are going to be 0. So this carbon, this mercury, those are 0. Those are both 0. Okay? Now after that, we have to balance these out. Okay? We have to balance. So the mercury has to balance with this oxygen. It has a +2, -2, so they're balanced. This carbon has to have a +4. Yes, this has a -2, but there are 2 of them. So that's a total of -4, so this has to have +4. Okay? Well, because the oxidation numbers of the carbon and mercury changed, look, mercury was a +2. You go to the other side of the equation, mercury is a 0. Whoa, mercury changed oxidation numbers. Carbon went from a 0 to a +4. It changed oxidation numbers. Therefore, this is an oxidation reduction or just a redox reaction. Okay? Now check this out. A little bit of bonus information here. The carbon went up from 0 to 4. It lost electrons. It went up in oxidation number. It was oxidized. The mercury went down, so it was reduced. I'm sorry, I know this was a longer video. I do apologize for that, but like I said, this stuff can be kind of tricky. So really make sure, go over this a couple of times. Come talk to me in class tomorrow when we work on the practice. If you have any questions, make sure you ask them. I'll talk to you guys tomorrow.